Now let us define polynomial. The word poly means many and nomials means terms. So the meaning of the word polynomial is many terms. Okay. Now let us take one example. X cube plus 2x square plus 3y minus 5. Okay. It's a polynomial because there are so many terms. Right? If you put equals to 0, then it becomes an equation. Okay? If you put equal sign, then it will become an equation. If you don't put equal sign, then it is simply a polynomial. Right? So the basic difference between polynomial and equation is this only. Whenever you find this equal sign, means it's an equation. No equal sign, then this expression is called a polynomial. And here in this polynomial we are using only one variable, so it's a polynomial in one variable. Okay, so here we will study polynomials in one variables only, and this variable we can take x, y, z. Okay, we can take either x or y or z. Now if there is only one term in the polynomial, one term, this is an example of polynomial. So here this x cube, 2x square, 3y, 5, they all are called terms of the polynomial. Okay, this x cube, 2x square, 3y, 5, they all are terms of a polynomial. So if there is only one term in the polynomial, then the polynomial is called monomial, because the meaning of the word mono means one. The word mono means one. So if there is only one term, then the polynomial is called monomial. For example, 2x or 3x square or minus 5y minus y cube. Okay, these all are monomial, right? Having one term only. Okay, even this 5 is also monomial. It's only one term, right? And here we just assume that the value of means here this 5 can also written as 5 multiplied by x raised to the power 0, and you know that any term raised to the power 0 is 1. So this is again a monomial. Now what if there are two terms? So if there are two terms in a mathematical expression, in an algebraic expression, two terms, then we call it binomial, because the meaning of this term, this word bi means two. So if there are two terms, then we call it binomial. For example, 2x plus 5, 3y square minus 6x. Okay, 3y square minus 6y. Since we are talking about only one variable, so I'll take only one variable. Then x cube minus 5x. So there are two terms. So this is these all are the examples of binomial. Now what if there are three terms? So if there are three terms, then we call it trinomial. Okay, because the meaning of this word tri means three. So if there are three terms, then we call it a trinomial. For example, x cube minus 3x square plus 5x. Okay, or 5y square minus 2y plus 6. There are three terms, so it's a trinomial. Okay. Now what if we have 4 terms, 5 terms, 6 terms? So for more than 3, we use only word polynomial. Okay, for more than 3, for 4 terms we just say polynomial. For 5 terms so for 1 terms, 2 term, 1 term, 2 terms and 3 terms we have specific name: monomial, binomial and trinomial. And for more than 3 we simply use a word polynomial, because the meaning of the word poly means many. Okay, so on the basis of the number of terms, these are the particular names. Okay, these are the types, we can say. So if there is only 1 term, we call it monomial; 2 terms, then binomial; 3 terms, then trinomial. Okay, now these numbers like 2, 6, -8, they are also polynomial. Okay, they are also polynomial. Okay, and they are called actually constant polynomial. Okay, means this 2 can also be written as 2x raised to the power 0, as I explained earlier. So here these all are example of constant poly. Now how will you identify whether the expression given is a polynomial or not? So let us take one example. 3x square plus 5x. Is it a polynomial? Yes, it's a polynomial. And here we have 2 terms, so it is a binomial. Okay, now what about this x plus 1 by x? So this second term 1 by x can be written as x inverse. Okay, here the power of x is negative, -1, which is not a whole number. Whole number starts from 0. So here this power is not a whole number. So this algebraic expression is not a polynomial. So for any expression, so the condition for an expression to be a polynomial is the power should be whole number. Okay, now what about this one? Root x plus 3. This is also not a polynomial. This is also not a polynomial. Why? Because root means power 1 by 2, and 1 by 2, as we have seen in the first chapter, this 1 by 2 is not a whole number, so it is not a this expression is not a polynomial. Okay, now what about this? It's a cubic root. Cubic root means power 1 by 3. Okay, plus y square. Here the power of y is 2. It's a whole number, but this power is not a whole number, so it is again not a polynomial. Okay, so any algebraic expression, if the power is not a whole number, then the algebraic expression is not a polynomial. Okay, now next is degree of a polynomial. What do you mean by degree of a polynomial? So degree of a polynomial means the highest power of variable. Highest power of variable in an expression or in a given polynomial. For example, if I write 3x square minus 5x plus 6. Here who is variable? X is variable. Okay, now see the power of x here, it is 2. Power of x here, it's 1. And here the power of x, we can say the power is 0 here. Okay, so here the highest power of variable x is 2. So the degree of this polynomial is 2. Okay, highest power of the variable. Suppose if I write y raised to the power 4 plus y plus 5. So first check whether it's a polynomial or not. Yes, the power is a whole number, so it's a polynomial. And the highest power is 4. So the degree of this polynomial is 4. Okay. Now see these three questions, these three polynomials. We have to find the degree of the polynomial. So see the first polynomial. Here the variable is x and the highest power of this variable x is 5. So the degree of the polynomial is 5. Right? In the second polynomial, the variable is y and the highest power of y is 8. It means the degree of the polynomial is 8. Here we don't have any variable, but this 2 can also be written as 2 multiplied by x raised to the power 0, or we can also write 2y raised to the power 0. Okay, we can take any variable x from x, y and z. So because x raised to the power 0 is 1, so again we'll get 2. So here the highest power of this variable x is 0. It means the degree of this polynomial is 0. Okay. So like on the basis of the number of terms, we have specific words for the polynomial, specific terminology for the polynomial. Similarly, on the basis of the degree or the highest power of the polynomial, we have specific terms for the polynomial. So if a polynomial whose degree is 1, so 1 degree polynomial is called linear polynomial. So a polynomial whose degree is 1 is called linear polynomial. 2 degree, if the degree of the degree means the highest power of the variable. Okay, if the degree of the polynomial is 2, then the polynomial is called quadratic polynomial. Quadratic polynomial. And if the degree of the polynomial is 3, then it is called cubic polynomial. Okay. Now what if the degree is 4, 5 and 6? So here in class 9 we learn up to here only. If the degree is 4, then it is called biquadratic, but you only just remember this 3. If the degree is 1, then it's linear, 2 then quadratic, 3 then cubic. Okay. Now 0 polynomial. The term 0 is called 0 polynomial. Okay, and the degree of 0 polynomial is not defined. Okay, here the degree of 0 polynomial is not defined. So this 0 is called 0 polynomial. Okay, no need to be confused. So we have discussed the definition of polynomial and how to identify whether it's a polynomial or not. Okay, if the power is a whole number, then it's a polynomial, otherwise it is not a polynomial. Okay, and then on the basis of number of terms, there are particular names, specific terms: monomial, binomial, trinomial. Okay, one term, then it is called monomial; 2 terms, then binomial; 3 terms, then it is called a trinomial. Similarly, degree, on the basis of degree. Now degree means the highest power of variable. Okay, so if 1 degree, then if the highest power of the variable is 1, then it is called linear polynomial. If the degree is 1, then it is called linear polynomial. 2 degree, then quadratic polynomial. 3 degree, then cubic polynomial. Okay, and this simple 0 is called 0 polynomial. Okay, that's it. Now let us solve exercise questions. Okay, this is first exercise of this chapter, exercise 2.1. So the first question is, which of the following expressions are polynomial in one variable and which are not? State reason for your answers. Means some mathematical or algebraic expressions are given and we have to identify whether they are polynomial or not. Also we have to justify we have to give the reason for our answer. So the first expression given is 4x square minus 3x plus 7. We have to check whether it is a polynomial or not. Okay, so as we have discussed already that if the power is a whole number, then it is a polynomial. Okay, so here the variable is x and the power is 2. Here the power is 2, which is a whole number. Here the power of variable is 1, which is again a whole number. And here we don't have any variable, but this can be written as x raised to the power 0, which is again a whole number. So here the power is, all the powers are whole number, so it's a polynomial. And since we are using only one variable, so we will write yes, it is a polynomial in one variable. Okay, because question is which of the following expression are polynomials in one variable. Okay, so yes, this expression is a polynomial in one variable. Second part of this question is y raised to the power 2 means y square plus root 2. See, we have to check whether the power of variable is whole number or not. So here variable is y. Okay, it's root 2. Root 2 is a constant. Power of variable, we have to check the power of variable only. Okay, here the variable is y and the power of this variable is 2, which is a whole number. Okay, and here if you write, you can write it as y raised to the power 0, which is again a whole number. Okay, but no need to write it again and again, means because y raised to the power 0 is 1 only. Okay, and here the power is 2, which is a whole number, so again it is a polynomial. So we will write yes, it is a polynomial. And since we are using only one variable, so yes, it is a polynomial in one variable. Okay, now third question is 3 root t plus t root 2. Now here variable is t, here variable is t, and see the power of this variable. Here the power of this variable is 1, which is a whole number, but here the power of this variable is not a whole number. Root t means t raised to the power 1 by 2, and 1 by 2 is not a whole number. Okay, so it's not a polynomial. So what we will write? We will write it is not a polynomial because the power or exponent, okay, the power or exponent of variable, here variable is t, so power or exponent of variable is not a whole number. Okay, here the power is not a whole number, so it is not a polynomial. Okay, now the next is y plus 2 by y. Okay, here also when you observe, you will find that here the power of variable is 1, but this can also be written as y plus 2y inverse, means y raised to the power minus 1. So here the power of variable is not a whole number, so it is not a polynomial. So we will write the same reason, it is not a polynomial, and you write the same reason because the power of exponent or exponent of a variable is not a whole number. Okay, and the last part of this question is x raised to the power 10 plus y raised to the power 3 plus t raised to the power 50. Okay, so here we have three variables x, y and t, and the power of each variable is a whole number. So yes, it is a polynomial. It is a polynomial, but the polynomial in three variables. So it is a polynomial in three variables. Okay, here we have three variables, so it is a polynomial in three variables. Now the next question of this exercise is write the coefficient of x square. In each term we have to write the coefficient of x square. So the first question is 2 plus x square plus x. Okay, coefficient means, suppose if I write x square plus x, so the number with this x square is called the coefficient of x square. Okay, coefficient of x, the number with x is called coefficient. Okay, so in each question we have to find the coefficient of x square. So in this polynomial, the coefficient of x square is, with x square we don't have any number, so if we don't have any number then it's always 1. Okay, means simply here it is 1 multiplied by x. So here the coefficient of x square is 1. Okay, now the second part of this question is 2 minus x square plus x cube. So in this question the coefficient of x square is, here we have minus 1. Okay, along with the sign we have to take. So here the coefficient of x square is minus 1. Okay, it's very simple. Whatever the number along with this term x square is called the coefficient. The next is, the third part of this question is pi by 2 x square plus x. So here along with this x we have pi by 2. So the coefficient of x square here is pi by 2. Okay, any number with this x square. And in the next question, root 2 x minus 1. In this question we have to find the coefficient of x square, but we don't have x square here. Okay, so what we will do? So we can write this, we can rewrite this expression like this. We can rewrite it as 0 multiplied by x square. We just assume that it was 0, so 0 multiplied by any term is 0. Okay, so here if you find this type of case, question is find the coefficient of x square, and here there is no x square, so we can write it like this. So from here we will find that the coefficient of x square is 0. Okay, so the coefficient of x square is 0. Okay, and generally we don't write 0 multiplied by x square, so it is 0 actually. So instead of writing this term we will write this. Okay, so here the coefficient of x square is 0. Now see the next question, question number 3 of this exercise. Question is, give one example each of a binomial of degree 35 and monomial of degree 100. So first we have to give one example. We have to write a binomial of degree 35. Now you should know the definition, okay, the meaning of binomial. Binomial means two terms. A polynomial with two terms is called binomial, and degree is 35. Degree means the highest power of variable. Okay, so here in this question we have to write a binomial with, or binomial of degree 35. Okay, we have to give an example, means we have to write a binomial whose degree is 35. So there are so many numbers. Okay, you can make it on your own. So binomial means two terms. Okay, the expression should contain two terms, then only it will be called binomial, and the degree should be 35. Degree means the highest power. So I will write 3x raised to the power 35 minus 6. Okay, see, there are two terms. Yes, so it's a binomial, and the highest power of variable is 35, so the degree is 35. Okay, you can write so many examples. You can also write y raised to the power 35 minus or plus 4y. There are two terms, so it's a binomial, and the degree is highest power, or the degree is 35. So it's a binomial of degree 35. Or you can also write root x raised to the power 35 minus 2. There are two terms. The power or the highest power of variable is 35, so degree is 35, and two terms means it's a binomial. So you can write so many examples. Okay. And second, monomial of degree 100. Monomial of degree 100. Monomial. So the meaning of mono means one. So the if there is only one term, then it is called a monomial. So here this expression should contain only one term and the degree is 100. Degree means the highest power of the variable. Okay, power of variable. So here we have to write only one term and the degree should be 100. So the answer can be there can be there can be infinitely many numbers. Okay, expressions. We can write y raised to the power 100. Okay, one term and the degree is 100. Or we can write x raised to the power 100. We can write 5x raised to the power 100. We can write minus 2y raised to the power 100. We can write root 2y raised to the power 100. Okay, we can write minus 1 by 2 x raised to the power 100. Okay, and we can also write 5t raised to the power 100. Here we have taken variable t. You can take variable x, y, z. You can take t, right, r, s. But generally we take x, y, z. Okay. So again there are so many examples we can write here. Now in the next question, question number 4, the question is write the degree of each of the following polynomial. We have to write the degree of the polynomial. Degree means highest power of variable of a polynomial. Okay, so in the first polynomial the variable is x and the highest power of x is 3, so the degree of the polynomial is 3. Okay, here in this case the variable is y and the highest power of y is 2, that is why the degree of this polynomial is 2. Here the variable is t, okay, and the highest power of t is 1, so the degree of the polynomial is 1. Here we don't have variable, but we can write x raised to the power 0, or you can also write y raised to the power 0, but in each case you will find that the degree of the polynomial or the highest power of the polynomial is 0. So in this question 3, the power or highest power or the degree of the polynomial is 0. Okay. Now see the last question of this exercise. Question is classify the following as linear, quadratic and cubic polynomial. So we know that linear means 1 degree. Okay. Polynomial whose degree is 1. Degree means highest power of the variable. Okay, then the polynomial is called linear. Quadratic if the degree is 2, and cubic if the degree of the polynomial is 3. So we have to classify the following as linear, quadratic and cubic polynomial. So here the degree of this polynomial is, the degree means the highest power of the variable. So here the degree of the polynomial is 2, so it is called quadratic. Okay, here the degree of the polynomial is 3, so it is cubic polynomial. Here the degree of the polynomial is 2, so it's quadratic. Here the degree of the polynomial means the highest power of the variable is 1, so it's a linear polynomial. Here the highest power of the variable or the degree is 1, so it's again a linear polynomial. Here the degree is 2, so it's quadratic. And here the degree is 3, so it is called a cubic polynomial. Okay, so with this we have completed the first exercise, which is very simple, very short, small exercise, but very important. Okay, so now you just practice these questions